Hi, I'm Paul. We're doing Leetcode must-know interview questions. Today's challenge is valid anagram. Given two strings, S and T, return true if T is an anagram of S, and false otherwise. An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. I mean, it says typically, but doesn't it have to use all the original letters exactly once? Constraints, let's see, one is, so the length of the strings, well, they're not guaranteed to be equal, but they are guaranteed to be between 1 and 5 times 10 to the fourth, 50,000. S and T consists of lowercase English letters. Follow up. What if the inputs contained Unicode characters? How would you adapt your solution to such a case? Okay, well, this is part of the Leetcode Hashmap category of must-know questions. So if you actually use a hash map, I don't think you have to change it at all because Unicode is the native data set of Java. So you have a hash map with a key of character and a value of integer. How many times does the character occur? We're not going to use, we're going to use an array to simulate a hash map. Now, if you want to use an array, you could still do it. I think, so the character in Java is going to be a two byte unsigned array. And so you would just need a bigger array. If all you have is lowercase letters, then you just need a 26 element array. If you have Unicode characters, I think you're going to need a 65,536 element array. I mean, I still think that will work. There are actually more Unicode characters than that, but I don't know. Well, you know what? I think we would have to kind of experiment with it a little bit to make sure how it's going to work. But anyway, Unicode is the default character set for Java, and it uses the what is it called? The something representation of the character. Anyway, I already spent too much time on that. Okay, let's kind of sketch through how we might solve this, and then we'll write the code. So we're going to sketch out a hash map here. I mean, it's going to look like a hash map because it's easier to sketch out a hash map than it is to sketch out a 26 element array. Even though we're going to use the array, we're not going to use the hash map. So we're going to use example 1. First thing we need to do is we need to go through all the letters in string S. So the first letter that we encounter is the letter A. And it occurs 1 time so far. Next letter is N. It also occurs 1 time. Next letter is A. A is already in there, so we're going to change that. It doesn't occur 1 time. It occurs 2 times. A, N, A. Next letter is G. Occurring 1 time. Next letter, R. Occurs 1 time. Next letter, A. Oh, it's already in there. All right. In that case, we'll just increment it. It is not 2. It is going to be 3. And finally, the last letter is M. one occurrence. All right, so we're done with S. Next thing we do is T. We go through T. And as we go through T, we do a lookup of each character in the hash map. If it's there, we decrement it. Now, if it's not there, or we've decremented the count to 0 already, we do not have an anagram. If we can go all the way through T and we wind up with a hash map consisting of 0 values, all 0 values, then we've got an anagram. So let's go through this. N, okay, the first letter is N. N is in there. All right. Decrement. Next letter, A. A is in there. Decrement. Goes from 3 to 2. Next letter, G. G is in the hash map. Decrement. G, A. Another A. A is there. We will decrement. What's next? R. R is in there. If at any point one of these goes negative, we're done. That's a fail. You got to return false. But R is in there. R is in there, and it is now going to 0. Next, another A. We have A. Decrement to 0. And finally, the last letter is M. This equals 0. All right, so that's what a valid anagram looks like. The whole hash map is zeros. All right, let's try to code it. Actually, I should mention one more thing here. There's like a really simple way to do this. It's probably not going to be the most efficient way to do it, because this is an O of N algorithm, or, well, they don't have to be the same length, do they? Is it still O of N, or maybe O of N plus M? We're going to have, let's say we did this. Let's say we took each string and converted it to a character array, right? And then sorted the character arrays. And then use the arrays.equals method to see if they're equal, and just return it, true or false. Well, we're not going to do that because this is considered to be a hash map question. So that's not what anybody is expecting to see if you get a question like this, is, sorting character arrays. That's also going to be n log n, right? N log n? Yeah, to sort it. So n log n is not as good as n. So yeah, I just mentioned that. You can do it. You have about 5 lines of code. It'll be very simple, but don't do it that way. All right. Let's take a look at the code. Okay, as we already noted, there is nothing in the constraints that says that S and T have to be the same length. So we could save ourselves some time, possibly, by comparing the lengths. So if S length is not equal to T dot length, then just return false. All right. we need our simulated hash map, our array hash map. That needs to be an array int count equals new int. All we have here are lowercase letters. So we need an array of size 26 for char c. We'll do an extended for loop in s1.2 char array. For every character, the count of character minus the lowercase a character incremented. Now, this int, if we declare an int array, Java will initialize everything in there to 0. Okay, again, we've seen this before, but if you haven't seen it before, characters in Java are just like numbers. The character count is considered to be a number, and you don't have to do any conversions back and forth. So if you have a character, and let's say you have a lowercase character, and you subtract the lowercase character a from it, you're going to get a number between 0 and 25, which is what we're going to use to index into our hash map array. All right, so we've loaded the hash map array. And now we're going to go through T and see if we've got an anagram. So let's say for, actually this is going to be just about the same, really. So let's do that. We'll say, why did I say S1? It's S. And this is T. For char c equals t dot to char array count, we're going to decrement. I don't know. Probably we should put a check in there to see if we're decrementing below 0. I don't know. We'll see at the end here if we lose a lot of efficiency by doing this, but we've gone through S, we've gone through T, and if it is a valid anagram, then every value in the array is going to be 0. For int I equals 0, I is less than 26, I plus plus. If count I, if it's not equal to 0, we got a problem. And we will have to return false. If we get through all of that and we haven't returned false, then we need to return true. All right, run it. I don't know what happened. Okay, accepted. Good. And then submit. All right. What is that? That's the runtime. Okay. So the runtime is good. We are ahead of 97.28% of people on runtime. I don't know, maybe the overhead of checking whether we've decremented below 0 is greater than just ignoring it and checking it at the end. So most of the runtimes are greater. This stuff out here is probably people, actually using hash maps. That would probably be the case on the memory too, right? Where are we on memory? We're right here. Yeah, so people actually using hash maps, something like that. Hash maps are very, very useful data structure, but if the only thing that you have is like characters and integers, just use an array. It's a lot more lightweight. It's a lot more efficient. Okay, that's it for valid anagrams. Feel free to like, subscribe, comment, and see you next time.